signal. Yes, but since the filter's in-band loss proves critical, the selectivity and out-of-band attenuation are quite inadequate. You can use it provided the filter characteristics are not changed. So the filter with very high image rejection usually appears between LNA and mixer. So they say that even though there is a possibility of swapping the position of LNA and the filter, but most architectures they prefer having the filter after the LNA only, so that the gain of LNA will lower the filter's contribution to the receiver noise figure. So even though you are going to amplify your noise using the LNA, but the filter unwanted noise contributed by the filter will not affect my circuit because LNA will have a huge amount of gain. And the filter has to be linear and selective. So it has to be linear. So it should not alter my message signal, and it has to choose which image frequency has to be rejected. So linearity and selectivity are the most important characteristics of your image reject filter. And you know, in RF, all the impedance should be matched to 50 ohms, right? So the LNA input output should be matched to 50. Filter input output should be matched to 50. So 50 is going to be the characteristics impedance of your transmission line. So it is a mandatory requirement in RF circuit to match everything to 50 ohm for a proper impedance match and maximum power transfer, which is very, very difficult actually, because the LNA what you are going to use will be made up of transistors, and you can never have transistors having input and output impedance of 50 ohms. It will be very, very large. So you have to bring down from that large value to 50 ohms. So it is going to be a very, very difficult task. And if you have an option between image rejection and channel selection, what will we do? Image rejection means outrightly rejecting my image frequency. Channel selection means selecting only my required message from the many signals. So if you have an option to choose between these two, or if you have these two methodologies, or we will compare which one is more suitable. So the desired channel and image have a frequency difference of omega if we have seen the desired signal and image, they differ in frequency between them by 2 omega IF. So to maximize image rejection, it is desirable to choose a larger value of omega IF. So whenever the difference between omega in and omega LO, and the difference between omega in and omega LO is going to be larger, we are going to have larger IF. When omega IF is going to be larger, the image will be at a far off distance from your desired channel. That is the logic. So you have to keep the image far away from the desired frequency. So that is possible if you increase omega IF. So increasing omega IF is possible only when the difference is going to be large. The difference is going to be large. Either my omega in should be high or omega LO should be less. So how large can 2 omega IF be? So what is the magnitude of 2 omega IF such that the image will be very, very far away from the desired channel? So in a heterodyne receiver, you know, from the RF frequency, I'm going to convert the frequency into low frequency. So for that, if you are going to keep on increasing 2 omega IF, then you require the filter to be highly selective, because at high frequencies, the filter has to be more sensitive. When you increase 2 omega IF, you are increasing omega IF. When you are increasing omega IF, the IF filter which is going to choose your frequency should be more selective, or it should have a very high sensitivity, which will make more burden on your filter side. So see, our goal is to reject image, but when you go for conditions to reject image, all other parameters are getting altered. So the complete circuit parameters have to be considered before even you think of